Hello everyone, we are GP Kruparani and Shashibala, BME final year students of 2009 to 13 batch of GRIT. Our final year project is Electromechanical CPR. CPR is the abbreviation for cardiopulmonary resuscitation, which is an emergency procedure that helps restore the circulation of blood after a person experiences cardiac arrest. Cardiac arrest occurs when the heart loses its function and stops circulating the blood to the whole body. Many vital organs can be damaged from the lack of blood flow. The brain, more than others, can be severely damaged if the blood is not supplied for a minimum of 4 to 5 minutes. Once the victim has received brain damage, the chances of recovery drop significantly. CPR is performed using a combination of rescue breaths and chest compressions. The three factors needed to perform successful CPR are quickness, forcefulness, and consistency. Manual performed CPR has several limitations. Humans experience fatigue. A major cause of inconsistency is fatigue. Losing consistency means stopping the flow of blood, and after some time, the patient's organs suffer from lack of oxygen. The quality of the compressions will be lower as the time elapses. All these limitations can be overcome using electromechanical CPR. The main components used in this project are the board, the CPR board, and the belt assembly, microcontroller and its related circuitry, and the power sources. The entire compressions of the device is achieved using this motor assembly. The motor assembly consists of the motor, the shaft, and the eccentric wheel. The motor assembly has been designed in accordance with the objective of keeping the device simple and modular. It will utilize a battery operated motor and driveshaft apparatus that will connect the belt with the board in order to generate the forces necessary to shorten the load distributing band. The driveshaft will feed the belt into the board via an opening on the side. The motor and the belt in the driveshaft will pull the belt and allows for the load distributing band to compress and decompress. The main component of the design is the board. The main assembly of the design is centered on the board that supports and secures the patient during application of chest compressions. The board is machined from new wood, which is a suitable material considering its high impact strength, machinability and cost effectiveness. The dimensions of the board are 24 inches length, 16 inches breadth and 3-inch width. The motor and the belt assembly are provided underneath the board. We used a 100 rpm 12 volt DC gear motor. It gives a massive torque of 30 kg per centimeter and 750 to 800 milliamps of current. And the drive shaft is a mechanical component for transmitting torque and rotation, usually used to connect one component that cannot be connected directly because of distance. Drive shafts are carriers of torque and they are subject to torsion and shear stress. Therefore, they must be strong enough to bear the stress. The compressions and decompressions are occurred in the following manner. The motor rotates in one direction and the eccentric rod attached on its circumference rotates along with it. During one half of the rotation, the eccentric rod comes down, pulling the belt attached to it in downwards position. This causes compression on the upper side, and during the rest of the rotation, the eccentric rod moves up. This results in the relaxation of the band attached to it. This principle provides accurate depth of compression. The main component which comes in contact with the patient is the load distributing band. The distributing band is used to deliver the chest compressions. It is an adjustable strap that covers the entire rib cage and pulls tight around the chest. It employs thoracic compressions because it produces higher blood flow compared to CPR consisting of sternal compressions only. The other component in the project is the microcontroller. Here we used Arduino Milano. It is a microcontroller board based on the Atmega 1328 microcontroller. It has 14 digital input-output pins and 6 analog pins, a 16 MHz crystal oscillator and a USB connection, and also a reset button. Microcontroller is used to switch on and off the relay. Relay is used to provide delay for the compressions. A relay is an electrically operated switch. The relay consists of a coil of wire inside it, which is wrapped around a soft iron core, and also when the current passes through this coil, it generates a magnetic field that activates the armature, and the consequent movement of the movable contacts inside it either makes or break the circuit. And when the current to the coil is switched off, the armature is returned by a force approximately half as strong as the magnetic force to its relaxed position. So, when the coil is energized with direct current, a diode is often placed across the coil to dissipate the energy from the collapsing magnetic field at deactivation, which would otherwise generate a voltage spike dangerous to semiconductor circuit components. In this circuit, we are using a transistor 2N2222. It acts as a switch and it allows you to turn on the relay.